No one solution fits all. So let's help the athlete to find a technique that might best suit their body at the time. So I strongly encourage coaches to try to use technology. Some of them are quite easy to use. Use technology to help you make an informed decision when you advise your athlete on the technique and the training plan.
Hi, Veni. It's my pleasure to have you on Evidence Strong Show. If you could briefly introduce yourself.
Hi, Alex. Thank you for having me here. My name is Veni. Full name Pui Wah. You can call me Veni. I'm an associate professor and an associate dean at the National Institute of Education, Nanyang Technological University in Singapore. My training background is in sports science with specialization in biomechanics. In short, we use the principle of physics, such as forces and movement, to apply in a sports setting, looking at how we can help coaches and athletes to train better, excel in their sport, and at the same time trying to prevent injury from happening.
Let's start with the why. Why have you decided to run this study?
I'm always interested in resistance training myself. So early on, even during my study time, I trained to be a resistance training coach, like lifting weight using machine. I was quite fascinated by all this dumbbell, barbell. Kettlebell was quite new back then. So I'm genuinely interested in how to train our muscle effectively so that we can do better in our sport and stay healthy. So why do I decide to do this study? It's actually not me, it is my student. So I was a professor teaching classes like many other professors. One of my master students, An Ching Nong, he's the first author of the paper. He approached me to say that he's interested to do a study in biomechanics for his dissertation. Our student can choose to take courses alone, or they can do a mini dissertation at the end of their master. So it is their choice. If they want more research experience, they can choose to do so. So Chanong approached me wanting to do a study in biomechanics. So I asked him, what is your interest? What sports do you do? What sports do you like? Because I think it is important to connect the academic part with the personal interest of a student. And he introduced me to the snatch movement in Olympic weightlifting. He is in particular interested in the starting phase of this movement. How do you lift the weight off the ground? The initial bit until you lift it up halfway at the maximum velocity. So he's very interested in the initiating phase of the different technique because he heard about different school of thought. Some coaches say that, some coaches say that. Because of inconsistency, he was wondering what technique is the best for him, his friends, and maybe the fellow athlete that he will be coaching in the future. In fact, there's a lot of study in the snatch movement in Olympic weightlifting. Most of the time, it will require a laboratory with force platform. There are research-grade equipment mounted in the ground. You can't take it anywhere. So it's on the ground, very accurate. Sometimes you can also put a transducer in the bar so that you can track the movement of the barbell. We can calculate the displacement, the velocity. There are other times that people use 3D motion capture system, which is very accurate and also quite complicated. So we identify a gap is that there's something that is very simple that we can take it to the field for the coaches to use and get instant feedback straight away. So we decided to explore what is in our lab that is wearable, portable, easy to use, with free software. Everything is easy to develop a method for coaches and athletes to use in the future.
All right, I have to ask, what was the in-shoe sensor you have used?
The sensor that we have is Low-Sol. It is a Germany brand, Novell. They do pressure sensor for a long time in our field. And at that time, they also bring up this new sensor called Low-Sol. That was quite a few years ago. So we have done some validation study of a Low-Sol in gait, so walking. And some running, but have not applied it in weightlifting and other sports setting yet. This Low-Sol you put inside the shoes, and the data can be transmitted to iPad, iPhone, or Android phone without any cable between the sensors and the collecting device. So it is very user-friendly. We decided to try to use this Low-Sol to see if we measure forces in Olympic weightlifting. There are some limitations, of course. The accuracy is not as accurate as the force platform, and it can only measure one directional force, like only the vertical upward, where in the lab, for the force platform, we can get the 3D, X, Y, Z. But for Olympic weightlifting, for this application, I don't think we need the horizontal force that much. So I believe the vertical force only, it may work. So we're going to try to use it in the setting. It is quite easy to use, and we don't have any issue collecting data. So I think at the time we don't know, but we try out, it seems to be working quite well. So that is the first piece of equipment. But in order to measure power, the force itself is not enough. We also need the velocity or how fast the barbell is lifting. So instead of putting transducer or using 3D motion capture system, we decided to use a simple video camera. Like anyone can use their phone to film the barbell from the side. We put a LED light at the end so that when the light emits, it is easier for us to do the video track. So we don't want to be manually click every single frame like that. We use an automatic tracking function, and that LED light really helps a lot in tracking the movement of the barbell. We also don't want to use any paid software, so that in the future, if people don't have access to university paid software, what do? So we decided to use Kinovia, which is a freeware that everyone can download and use, and it's quite good in doing 2D video analysis. We don't need 3D, it's just 2D. We track the barbell movement by the light, and then we can calculate the velocity. So with the force measured by the in-shoe sensors, with the velocity that we derive from video, we combine the two, we can calculate power. So power, from a physics definition, power is force times velocity. We measure the force, we measure the velocity, then we go ahead and calculate the power. So that is the method that we employ.
Awesome. So one more thing we have to know is what type of weightlifters, level, age, maybe sex, what type of weightlifters did you use as your participant?
So we write on my student channel his personal contact, because he participates in the sport, he knows the athlete, he knows the coach. And it is very important that through his contact, we have access to the athlete and we have access to their training venue. So we invited the Singapore national athletes. They're all training in the national team at the best form that they could. They are actively training and competing. We have 6 participants in total, 3 males and 3 females. For the females, they were about 23 to 27 years old. The guys 24 to 26 years old. So about in the mid-20s. The weights of the snatch attempt for the female happened to be all 48 kilo. For the guys, it ranged a bit from 86 to 106 kilo. So they were the best athlete that we could find in our country, Singapore, at the time. And I'm thankful that all of them are willing to step forward and let us collect data on them.
That's awesome. How big is the national team of Singapore?
It's small and it ranged from time to time. So these 6 athletes, in a way, they are good representative to whatever we can access, and they are free to do it. So it's very small.
What we need to know now is the whole procedure. So you said you tested snatch, you came to the elite athletes facility, you set up the camera and put the insoles into the shoe, and what happened next?
Okay, so they will warm up in their usual routine, and we collected free trial of their snatch at about 80 to 90% of the maximum. So we don't want to get pushy to the limit. So 80 to 90% is usually where the peak power will occur. So each person, we collect a free trial. In between, we give them plenty of time to rest. And when we analyze the reliability of this free trial, they're quite repeatable. After that, we pick one best trial of these 3 and we do a more in-depth analysis. So they come in, they warm up, and then we try whether the sensor is working. We mount the LED light on the barbell, we set up the camera, and then off they go. After some warm-up, we do 3 actual trials. That's it. So it takes very little time from the athlete. And after that, we go back and analyze the data.
You said you measured force and velocity?
And also the displacement or the barbell movement, like the shape when you lift up, is it in a straight line or is it, the pathway?
The bar pathway. Okay, awesome. Are we ready for the results?
Yes, we are.
Okay, what have you found?
Okay, so we only look at the starting phase of the snatch. So it's not the entire movement, just how the weight lift up the ground until it reaches its peak velocity. Because that's very important. If you fail, usually people fail at that time on. That you don't generate enough speed, you can't go under, you can't go up. So we focus on the very beginning phase. There are first pull and second pull, and in between there's a very short transition phase. So we look at how the velocity was generated during the first pull, transition phase, and the second pull. I will summarize 3 main points. The first one is that out of our 6 participants, females and 3 females, they all use quite different technique. And the amount of force that they generated are very different. So there's no one way that fits all. In general, males lift maybe the force and the power in males are about twice as much as the female. So that is the force and the power production. However, we also observe that the velocity, how fast the weight is lift up, is the same or very similar between the males and females. This is quite interesting because the males are lifting heavier weight than the female, but from our measurement, it's very consistent. The speed that they can lift up this weight, pretty much the same. So regardless of the actual amount of the weight, the maximum speed that a person can generate probably can reach the similar level between male and female. So the implication of this is we probably should not just look at the speed. We should measure other measures such as the forces and the power, because the speed, if you use your maximum power to lift up a weight, everyone maximum speed probably reach about the same. So speed alone may not be sufficient. The last observation that we have is about the pathway that you've mentioned. So in the 1970s, people start to talk about this S shape. Like when you lift up the barbell, you observe from the side, there should be a S shape of how the barbell is lifted up. So in the literature, it has been identified there are 3 types of S-shaped pathway. If you imagine your foot is here, you draw a vertical straight line. Say with the barbell, how many times that it passes through the straight line will determine whether you're type 1, type 2, and type 3 in your S-shaped chest pathway. Among our 6 participants, we've seen all 3 pathways. So some people cross the bars 2 times, which is type 1, very common. Some cross 3 times. And there's also one participant, it doesn't cross even 1 time. So if the straight line here, the barbell only go backward. It never cross even 1. So among 6 participants, there's no a single dominant style. So some just go backward, some will pass 1, 2 times, other will go 1, 2, 3 times. And they are all very successful in lifting the weight that they want to lift. So we don't have enough data to suggest whether it's because of the torso length, it's because of the leg length, of the ankle flexibility. We don't have enough data to draw a solid conclusion. However, we do observe that these are high-level athletes. They find their own way of lifting the heavy weight effectively. And we probably should not limit them to one style. So maybe for you, crossing 3 times is the best for you. For another athlete, it could be 2 times, or maybe you want the one who go backward, never cross even 1 time. So I'm quite amazed to see that among 6 people, we see all 3 different styles that we find in the literature. So as a take-home message for me is, okay, we need to probably individualize the training rather than say one method fits all efforts. We, as a coach, perhaps will help the athlete to find what is best for them. We can use simple methods such as putting a video on the side to track the barbell to see how it moves. So I believe the method that we have developed in this study will be quite useful for the coaches, because it shows that using free software, something very simple video, you can track the pathway and it can have a meaningful interpretation on the technique. So if I summarize again, the first one, we find variation. The second finding is that a male lift, the forces and the power generated by the male are about twice as a female, but the speed is about the same. The last one is this S-shaped pathway. We see 3 different styles among the 6 athletes. So I advocate to go for individual learning pathway rather than one solution that fits all.
Do you remember the velocity? What was the velocity? Because you said this was very stable between female and male lifters. So about 80 to 90% snatch, what is the velocity?
Okay, we analyze up to the peak velocity and then we stop, right? The peak velocity is about 2 meters per second. So it ranges from about 1.99 to about 2.15 meters per second. So on average, it's about 2 meters per second when it reaches the peak.
So pretty stable.
Pretty stable. And we compare our finding with the literature because the method that we use are new. So we also compare the force measurement and the velocity measurement that we have with other literature that's using more established method, and they are in line.
What the coaches should be aware of if they consider using this method?
Okay, so I think we need to do a proper calibration. So if you use 2D analysis, you need to set a known length first. You tell the video, this is 1 meter. So everything else is scaled to that 1 meter. So it is important that when you do the scaling, we have a meter stick that put underneath the barbell in the same plane as where we put the LED light. So it's important that everything is in line. So if your barbell is 3 meters away from the camera, where you put the light, the calibration stick that you use must be in the same plane. If you put it too in front, too far backward, then everything will be off because the scaling from pixels to meters is wrong in the first place. So be careful when you do the calibration. If you were to use the local sensors, the calibration also need to be done quite carefully. So in the beginning, the software will prompt you to, lift off one leg and put all the weight on the other one. Then you calibrate. They will use the participant's body weight as the calibration. So we have to enter the weight correctly. So when you lift up the leg, just make sure that all the weight is really placed around the ground so that the sensor is calibrated correctly. So I would think they're quite simple to do, but need to pay attention during the calibration process. So if you have anyone to recommend who want to do their master or PhD study in Olympic weightlifting, please ask them to contact me. So in the next study, we hope to maybe look at have more data, more sample size, and also trying to figure out the reason on why certain athletes use certain technique, and is it better for them in short term and also in the long term. It may be good for now, but if it's prone to injury, we also don't want it to happen. So I'm very open to take on new students who might want to do more research in Olympic weightlifting.
That's great, Veni. Thank you. All right. If anyone is watching and would be interested, they should contact you immediately.
Thank you.
All right. So I will give you an opportunity to give the last message to coaches and lifters. What should they take away from your study?
No one solution fits all. So let's help the athlete to find a technique that might best suit their body at the time. So I strongly encourage coaches to try to use technology. Some of them are quite easy to use. Use technology to help you make an informed decision when you advise your athlete on the technique and the training plan.
Sounds good. All right. I usually finish the interview with 2 short questions. And the first one is, what is your favorite exercise?
I am a springboard diver, so I still watch a lot. So I like to do somersault and flip, and therefore I also watch similar sports such as gymnastics and acrobatic movement.
That's awesome. All right. And the last question is where people can find you if they want to follow your work or contact you for a research project.
So you can find me on LinkedIn, X, Google Scholar, ResearchGate, or drop me an email anytime.
Excellent, Veni. Thank you so much for today. It was a pleasure.
Thank you for having me.